Good day, everyone. Today's lesson is about network exploration. As we know that our EZVIZ devices, including IPC, IoT devices, are basically connected wirelessly through the Wi-Fi protocol. And we also have an alarm product, A3K, in which the wireless association protocol between the hub and the sensors is ZigBee 3. Today we mainly talk about the content of Wi-Fi. There are main 4 parts in this lesson. The first part is network basics. We mainly explain the knowledge and basic concept of the network, which will help deepen our understanding of the network. The second part is network equipment, including cable, router, switch, and AP. We will not go into a very in-depth explanation, mainly introduce the products sold by EZVIZ overseas. The third part is Wi-Fi related knowledge, including the history, protocol, bitrate, and the strengthened Wi-Fi signal method. And the fourth part is a brief introduction to the network-related technologies, including mesh and MIMO, beamforming, and PoE. Now let's move to the first part, the network part. If you have majored in computer network-related majors or read some book about this knowledge before, you should be familiar with these 2 diagrams, which are our common network module, the OSI module, and the TCP/IP module. The 2-layer devices and the 3-layer devices, we often say refer to the hierarchical devices divided according to the OSI module. Here we mainly remember which layer of IP and TCP protocol are transmitted, which will be helpful for the later lessons. First, let's have a look at the concept of IP and MAC. IP address is an internal protocol address. It's a numerical label such as 192.168.1.1 that is connected to the computer network that uses in the Internet Protocol for communication. An IP address serves 2 main functions: network interface identification and location addressing. Generally, the IP address refers to an IPv4 address, which is a set of 32-bit binary numbers. The IP address includes the network number and host number, and they are distinguished by different subnet masks. IP addresses are applied at OSI layer 3, the network layer. The IP addresses are written and displayed in human-readable notations, such as 192.168.1.1 in the IPv4. The size of routing prefix of the address is designated in CIDR notation by suffixing the address with a number of significant bits. For example, 192.168.1.1/24, which is equivalent to the historically used subnet mask, which is 255.255.255.1. So, as we mentioned before, the IPv4 defines an IP address as 32-bit number. However, because of the growth of the Internet and the depletion of available IPv4 addresses, a new version of IPv6 using the 128 bit for the IP address was standardized in 1998. So IPv6 deployment has been ongoing since the mid-2000s. So this is the IPv6 address, which including 128 bits long, and is divided into the segments for every 16 bits. An IPv6 address consists of the network prefix and the interface identifier. For the IPv6 abbreviation, you can refer to this picture. The leading 0 in each group can be omitted. A group of consecutive zeros contained in the address can be replaced by the double colon. About the MAC address, which is Media Access Control Address, which is the unique identifier assigned to the Network Interface Controller, NIC, for use as the network address in communication within a network segment. This use is in common in most IEEE 802 networking technologies, including Ethernet, Wi-Fi, and Bluetooth. Within the OSI module, MAC addresses are used in the Medium Access Control Protocol subplane of the data link, which is the layer 2. So basically, the difference between the IP address and MAC address is that IP address can be compared to our phone number. It can be changed according to different network environment, just like our mobile phone number can be changed according to our needs. However, the MAC address can be compared to our ID number, which is unique when the device leaves to the factory. Its network card will be given a MAC address, which is equivalent to the identity information of the device network. So this is unchangeable. Then let's talk about the DNS. Why do we need to know this? Because we will encounter this knowledge in the following learning. So when we want to visit the website, we need to enter the IP address, since the IP address is composed of numbers, and it's difficult for the user to remember it. Therefore, domain names are created to represent the addresses of different server groups, which is convenient for the user to access. The working principle of DNS is shown in this figure. Here is our client. When we want to visit the website, we will enter the domain name of the website. The access request will first go to the local DNS server, which will be provided by your local carriers or your company. If the local DNS server is not saved the domain name you passed, then the local DNS servers will transmit the request to the root server to resolve the domain name. And the root server will give you the response that the domain is managed by the .com zone. Then the local DNS server will access the .com domain servers to find the specific IP address that corresponding to the such as www.google.com. And then .com domain service will respond the main area of the google.com. Then the local DNS server can access to the google.com domain service here to find the corresponding IP address to the domain name. Then our clients can access to the website you want. If the local DNS service has already saved the domain name before, when you want to visit the website, such as Google websites, then the request will send to the local DNS service, and the local DNS service will be directly to access the google.com domain service. Now let's move to the second part, network equipment. We mainly introduce the EZVIZ product. First, let's have a look at the network cable. We mainly list three kinds of identification of the network cable: the C85E, C86, and C86E. All these kinds of the cable, the effective transmission distance are 100 meters. And for the different type of the cable, the transmissible signal are different. For the Super 5 cable, it supports transmit 100 mega signal. And for the 6 cable, it will transmit the gigabyte signal. And for the Super 6 cable, it will support to transmitting the 10 gigabyte signal. According to the identification of the service of the cable, we can distinguish different types of the network cable. And if the logo on the surface is not clear, it can be distinguished by the inside of the network cable. Such as this picture, if you see the white cable inside the network cable, it should be the 6 or Super 6 cable. And there's a note here. When using the highly interference environment, you should select the shielded network cable. The second network equipment is router. So here are three key features about the router. The first one is that it connects multiple network segments. The definition of different network segments is that the IP network bits of two network devices are different. Then we can call they are in different network segments. And it works on the third layer of the OSI model. The third layer, which is the network layer. And it works through IP. The routers transmit data through the IP address. In a small network of an ordinary home, a router is usually used as the interface for connecting to an external network. The next network equipment is switch. It works on the second layer of the OSI model, which is data link layer, and it works through MAC address. The key role of the switch is used as extended network. There are two concepts about the network expansion. One is to expand the number of channels, and the other is to expand the diffraction length of network. Unlike the router, switch is generally used to expand the number of network channels under the same network segment. The last network device is the AP, which is not very common in our environment or our home. The AP is the access point, generally translated as wireless access node. It can convert wired signals into the wireless signals, and it can extend the coverage of the network. And the AC is used in conjunction with the AP, which is used to control and manage the AP device. So what kind of the scenarios will this device be used in? Let's take an example. So when we lived in the hotel, we usually don't see the router in the room because the hotel's network deployment is to use one AC to manage the APs in multiple rooms. Then this is the basic summary of the all network devices that we mentioned. So let's see the OSI module. The router is on the third layer, and switch and AP are on the second layer. About the router, the main functions are the inter-network communication, and the address is based on the IP address, and the IP address allocations and management, and is used for the wireless or wired device access. And for the switch, it's used for the data exchange and forwarding, and it's used for the addressing based on the MAC address, and it's used for the extended network port. And about the AP, the main functions are the convert wired signal into the wireless signal, and it can use to extend the coverage of the network. And about public network access, only the router supports the public network access, while the switch and the AP is only used under the LAN. And about firewall function, only the router supports the firewall function because it will connect to the public network, and switch and AP do not need this function. So this is the typical topology of the SMB. From the left, you can see the internet network, and the data will go through to the routers on the big building or your home, and it will transmit the data to our core switch. And AC is connect to the core switch, and then it will divide it to the different access switch to connect the different AP or other network device. Then we can use the laptop or pad or the terminal IP cameras to get the data with the wireless method. Now let's move to the third part, the Wi-Fi knowledge, which is the core key methods, key features about this lesson. First, let's have a quick look about the Wi-Fi history. In 1885, Hertz discovered the radio waves, and in 1894, Marconi begins experiments on the long-range wireless signal transmission and reception. In 1971, the first wireless network was born in Hawaii, which is AloNet. And in 1985, FCC allows use of WLAN technology in industrial, scientific, and medical radio frequency bands. specify that the transmit power of the wireless device cannot exceed 1 watt. And in the 1990s, the IEEE established the famous 802.11 working group. In 1999, IEEE officially released the 802.11b, which is the 2.4 GHz band standard. And at the same time, it also released the 802.11a standard, which is 5 GHz band. And the last things in 1999 is that the WECA was established. Nowadays, Wi-Fi technology is becoming more and more mature, and it will spread to every corner of the world. So basically, Wi-Fi, the essence of Wi-Fi is radio waves. And let's have a look about the Wi-Fi protocol. From the original 802.11 version, it derived it to the different version, including 802.11a and 802.11b version, or G version, N version, AC version, and AX version, till now. As you can see from this table, Wi-Fi has two working bands, which is 2.4 GHz and 5 GHz. The only difference among of these different versions is the max bitrate. So both bandwidths, 2.4 GHz and 5 GHz, are unlicensed bands. They can be used without authorization as long as they meet the standards. In other words, installing the wireless router at home and sending and receiving Wi-Fi signals does not require anyone to approve it. According to the characteristics of the two frequency bands of Wi-Fi, the 2.4 GHz and 5 GHz, we can compare their advantage and disadvantage. In the cover radius, the 2.4 GHz is up to 100 to 200 meters, while the 5 GHz is up to 80 to 130 meters. So we can see that 2.4 GHz, the signal coverage is wider than the 5 GHz. And about the penetration ability, the 2.4 GHz performance is better than the 5 GHz because 2.4 GHz can go through about 2 brick walls, while the 5 GHz can only through the 1 brick wall. As for the bitrate, the 2.4 GHz is up to 300 megabytes per second, while the 5 GHz is up to 1 gigabyte per second. So we can see that 5 GHz bitrate is larger than the 2.4 GHz. And about the environmental interference, the 2.4 GHz is better than the 5 GHz because devices operating in the 5 GHz band are less than 2.4 GHz bands. So the environmental interference is the frequency. The 5 GHz is smaller. And about the 2.4 GHz, the spectrum range from 2.4 GHz to the 2.4835 GHz, with a total bandwidth of 83.5 mega. And it's divided into the 13 channels, and each channel is 22 MHz wide. In different countries, we use a different bandwidth channels about the 2.4 GHz. So normally in China, we use the channel 1 to channel 13. And the other areas and the other countries are different. You can refer to this form. Among these channels, only the three groups of 1, 6, 11, or 2, 7, 12, or 3, 8, and 13 are completely uninterrupted, showing a congestion level in the 2.4 GHz band. It's like a very narrow road. There are a lot of cars on the same side. There are frequent traffic jams, which will inevitably lead to the decline in the speed of traffic. About the 5 GHz, the spectrum range from 4.910 GHz to 5.875 GHz, with a bandwidth of more than 900 megabytes, which is more than 10 times that of the 2.4 GHz. 802.11ac standard enabled routers and mobile phones can freely combine these available channels. It uses the 20 megabytes, 40 megabytes, 80 megabytes, or even 160 megabytes bandwidth. With many channels, large bandwidth, low interference, and fast peak download speed. So in this figure, you can see the blue part is available in China. Now let's have a look at the factors that affect the Wi-Fi speed. For the 2.4 GHz, there are two main factors, but you can see the different technologies in this standard to affect the Wi-Fi speed, including the MIMO technology and up to 4 antennas, and add the double channels bandwidth to 40 megabytes. So if we plus all the factors, then the single antenna theory maximum rate is up to 150 megabytes per second. And in the 5 GHz, there are more factors which can influence the Wi-Fi speed, including the MIMO technology, and it supports up to 8 antennas, and the channel widening supporting up to 160 megabytes. And it also has the new technology, which is 256 QAM, high order moderation. And if we add these all factors, then the single antenna theoretical maximum rate up to 433 megabytes per second. So, since we have 5 GHz Wi-Fi technology, why do we still need to use the 2.4 GHz Wi-Fi? There are two main reasons. The first one is compatibility. So in the early days, a large number of mobile phones, computers, and televisions only support the 2.4 GHz, and they must be compatible with these devices. And the other reason is about the coverage. As we mentioned before, the 2.4 GHz coverage is better than the 5 GHz because of the low wavelength and small signal loss, a strong penetrating ability. So that's why most of the EZVIZ cameras still support only 2.4 GHz, which is based on the advantage of the 2.4 GHz. These are the normal product of the routers on the recent market. So the single attendant, the routers, it supports 2.4 GHz. And on the package, you can see there's a bandwidth data here, which means it can support 150 megabytes per second speed rate. And about the second one is the double antennas router. It supports the 2.4 GHz and 300 megabytes per second speed. And the third one is we also can see the 3 antennas and 4 antennas. So the difference between these two routers is the 4 antennas router support both 2.4 and 5 GHz, and it has the more higher speed on the 5 GHz. And this is the basic parameters of the recent dual frequencies router bitrates. So these are only the theoretical limit rates in the 2.4 GHz and 5 GHz. So in fact, the bitrates during our use, it will be different from these parameters. In our daily life, our users or ourselves often encounter the problem of slow network speed. Specifically, it caused by the following reasons. The first one is older internet devices or lower performance. So it's time to update your devices. And the second one is about cable, the network cable, or the crystal head damage, or aging, or the poor quality. So it's time to replace the cable. And the third one is the configuration is incorrect of your internet devices, such as DNS configuration error. So you need to check all the settings into your routers or the other internet devices. And the fourth one is terminal software problem. So you need to killing the virus. And the fifth reason is about the Wi-Fi routing problem. The Wi-Fi signal received by the mobile phone is mainly a superposition of 4 effects of reflection, diffraction, diffusion, and penetration. The latter 3 effects are all related to the frequency of the signal, and the higher the frequency, the worse the ability to diffract and penetrate. Here is the attenuation of the Wi-Fi signal under different obstacles. So for the a 3 dB reduction means that the signal strength is reduced to the half of the original signal. And if a 10 dB reduction means that the signal strength is reduced to 1/10 of the original. And if there is a 30 dB reduction, means that the signal strength is reduced to the milli-original. And this film shows the different obstacles with the signal attenuation. For example, the 8mm board, the signal attenuation will be the 1 to 1.8 dB, and the 40mm wooden doors, it it will show the 2 to 3 dB reduction. And for the 12 mm glass, it will cause the 2 to 3 dB reduction. And about the 25 centimeter, the segment wall, it will cause the 20 to 30 dB reduction. And about the wall, the normal wall, it will cause the 15 dB reduction. And about floor, it will cause 30 dB reduction. And the elevator will cause the 20 to 40 dB reduction. And below the objects around you will cause the interference to the Wi-Fi signal, including the television, microwave oven, fridge, Bluetooth, glass, mirror, water, and metal. There are different scenarios about signal interference. So can you find the obstacles that can influence the Wi-Fi signal? Let's begin with the first picture. You can see the router is on the metal shell. So the metal is the main obstacle to cut off the signal transmission. And in the second picture, obviously the wall is the interference signal obstacle. And the third one, you can see the mirror is near to the router, then is an obstacle to influence the Wi-Fi signal. And the fourth picture, the router is installed on the fridge. The fridge is the electronic product, and it also made of the metal, so it can also influence the Wi-Fi signal. And the fifth picture, can you find the obstacle? So you can see there's an electronic light, the Christmas tree, which is also can influence the Wi-Fi signal. And the final pictures, you can see there is the microwave under the router, which is the obstacle to influence the Wi-Fi signal. Normally, IP camera will occupy more network bandwidth than the normal terminal. So it's necessary to ensure a good network environment for our IP camera. And we can find a lot of network bandwidth text too on the internet. The user can download the app called Speed Test for testing, or use mobile phone or computer to log in to the website. And the other tools for detect Wi-Fi signal is the Wi-Fi analyzers and the speed test master. Wi-Fi analyzer will give you useful information about wireless signal around you. It can help you to find a better place for Wi-Fi receiver, and gives you the information about each one Wi-Fi channel. Show the signal strength in history graph, and it also can recommend you best channel for new AP. The Wi-Fi analyzer is only for the Android system, and the speed test master it supports both Android system and iOS. So this is the basic steps about the how to detect your Wi-Fi signal. And you can see the result after the testing the Wi-Fi signal. There are 3 different results. The blue lines is the signal means the signal is strong, and the camera can be stably connected. And if you see the yellow one, it's like the warning that the signal is general. The cameras may sometimes drop offline, or the live view or playback is not ideal. And the red line shows the bad signal of your Wi-Fi. So it cannot guarantees that stable access about your Wi-Fi products. And this is the test details about this Wi-Fi signal detection tool. If the current channel interference is very large, then you can choose to change the channel. And how to enhance the Wi-Fi signal? The first method is choose the right location for the router. There are 4 tips about choose the right location. The first is the shorter the distance, the better. So try to put your router in the center of the house. And you need to make sure the Wi-Fi signal lasts through the wall. Best there's no wall between your routers and your network devices. And do not put the router in the distribution box at home. It will cause the signal interference. And keep the router as high as possible and avoid obstacles such as washing machine or the microwaves, etc. The method 2 is to adjust the angle of the antenna reasonably. So you can see from this picture, this is distribution map of the Wi-Fi signal. It can be seen that when the antenna is placed vertically, the signal coverage is the widest, and the signal strength is also strong. So we recommend that you need to put the antennas vertically. Then you can get more stronger Wi-Fi signal and a stable Wi-Fi signal. And in our user manual of W3 or W3C router, you can see the recommendation about router's position. The third method is to avoid environmental disturbances. For example, you need to keep your router as far away as possible from the microwave Bluetooth device, and use the dual band routers device supporting 5 GHz. Use Wi-Fi in the 5 GHz band as much as possible, and you can change the channel configuration of the router. The method 4 is to restart the router regularly. Overheating, aging, and excessive downloading will reduce the signal coverage. Then you can also consider reboot the router regularly. Wi-Fi signal can become faster and more stable after reboot the router. And the 5 methods is to use wireless extender to extend the signal. If your home place or the position is very large, you can choose the wireless extender to extend the Wi-Fi signal. So there's the tips about this method. Do not put the wireless extender in the place where the original signal is not good, which will lead to signal instability. The method 6 is to use the AP to extend the wireless signal, which is similar as the previous method to use the wireless extender. You can install the many AP in the different rooms and use the one AC to control all the AP. And also you can use the mesh router kit to extend the Wi-Fi signal. The Wi-Fi security problems that accompany the widespread use of Wi-Fi. This is the basic data about in China. The home Wi-Fi is most severely hacked into. On average, 13.1% of Wi-Fi will be squatted every day, and 66% of public Wi-Fi is not secure enough, and risky Wi-Fi is connected about 24 million times a day. Therefore, nearly 100 major property loss incidents caused by the fake Wi-Fi. The average loss amount of each event is nearly 50,000 yuan. There's 5 tips to enhance home Wi-Fi security. The first, adopt WPA or WPA2 encryption. 2. Set the hidden SSID so that the bad guys cannot easily find my home Wi-Fi. 3. Modify the router password for backend access and the Wi-Fi access password in time. You can set a complex long password. And 4. Enable MAC address filtering function and bind frequently used devices. And 5. Install the security software on your mobile phone or the PC. Here are the recommendations of the public Wi-Fi network. First, do not automatically connect to the Wi-Fi network. Don't forget to turn off your phone's Wi-Fi when you are not online, just to prevent your phone from being caught by phishing Wi-Fi. And there's another way. You can change the Wi-Fi connection to manual to master the initiative of the Wi-Fi connection. Second, do not connect Wi-Fi you don't recognize. Some fake phishing Wi-Fi are named after public Wi-Fi names, such as airports and cafes, making it difficult to discern the true and false in order to entice everyone to click and eventually intercept the highly sensitive information, such as password in the mobile phone. So everyone should be extra pay attention to it. Third, do not use strange Wi-Fi to do online shopping. Under public Wi-Fi, be careful not to log in to your any account and password related to payment and property. If you really need it, just switch the network to mobile data. And fourth, use Wi-Fi security software to detect and then connect to the internet. Now let's move to the final part, core techniques, including the mesh, MIMO, beamforming, and PoE. In this part, we only need to do the simple understanding. The first technique is mesh. In a common network topology, once a node fails to connect, the terminal devices cannot access to the network. In the mesh network topology, once the node cannot be connected, and the terminal devices can still access the internet normally. The mesh network is the multi-hop network developed from the Hawk networks and is one of the key technologies to solve the last mile problem. Wireless mesh can communicate with other networks. It is the dynamic network architecture that can be continuously expanded, and any two devices can maintain wireless interconnection. And let's have a look at the advantage of the mesh technology. The first is load balancing. When the load of the certain backhaul frequency band is too high, such as this the 5 GHz network is congestion. The system will automatically switch to the data to another backhaul, the frequency band to balance the network traffic and reduce the congestion. The next advantage of mesh technology is seamless roaming. For example, you can see this picture. If we install 2 routers, the node A and the node B, when we go from the node B to the node A, it will intelligently detect and automatically switch our connection to the optimal node. And the network will not be disconnected during the switching process. And the ad hoc network is that connections can be established between different network nodes. And when we communicate, it can automatically choose the optimal path. If a link goes down, there are other links to support. And the AP band steering. The advantage of these features is that the mesh terminal will evaluate the connection strength between all potential clients and the AP, as well as the rate of physical connection to provide a better connection path. The robustness reflects the strength of the network connection. When one of the links fails, it can quickly switch to another link to ensure the normal operation of the entire network. Instead of the traditional data transmission, the MIMO module is the 2x2 module. It's multi-input and multi-output. There are different links to transmit the data, and the speed will increase as the number of the antennas increased. The next technique is beamforming. Beamforming is the electromagnetic radiation mode of the group of antenna systems. Simply put, beamforming is a technique for constructing antenna radiation patterns, as shown in the case 2 below. The last technique is PoE, Power over Ethernet, which provides DC power and simultaneously transmits data without changing the existing Ethernet cabling infrastructure. There are 2 types of the PoE device. The first is PSE, the power sourcing equipment. For example, the PoE switch, the PoE MBR, etc. And the PD is a powered device, such as PoE IP camera, PoE AP, etc. Thank you for the listening.